we want to express the area of a rectangle that is inscribed inside the circle x squared plus y squared equals 9 with its vertices on the circle as a function of only x. So here is the circle x squared plus y squared equals 9. It's centered at the origin with a radius of 3. We want to express the area of a rectangle that's inscribed inside this circle. So I'm going to draw a representative rectangle here with the vertices or the corners of the rectangle on the circle. So I'm going to go ahead and sketch one example of a possibility as best I can here. So here is a rectangle that's inscribed inside of the circle, and I want to represent its area as a function of x. Well, this coordinate point up here is some point on x squared plus y squared equals 9. Let's call it the point x comma y. Now, if I'm interested in the area of this rectangle here, so the primary equation is the area of a rectangle. In general, the area of a rectangle is base times height. Well, the base of this rectangle is going to have a length of 2x, because if this is the generic coordinate point x comma y, from the origin, I would be going x to the right and y up. So that makes this distance here x, so this little distance is x, and because of the symmetry of this rectangle that's inside the circle, this distance over here is also x. So we have a total of 2x for the base, and then, as I said, if I go from the x-axis up, that's a distance of y, and again, because of symmetry, this is also y, so we have that the height of the rectangle is 2y. So the area so far, being base times height in terms of this diagram, is a base of 2x and a height of 2y, or 4xy. Now I want this to be a function of only x, meaning I'm going to need to eliminate y using some constraint equation. So the constraint equation, or the secondary equation that I'm going to need, is some equation that involves x and y, right? That talks about the limitation. Well, the limitation, the restriction on this rectangle, is that it's stuck inside of this circle. And we know that this circle has an equation, x squared plus y squared equals 9. So this is my constraint equation. It's an equation that relates x and y and involves the circle because it is the circle. So my constraint is x squared plus y squared is equal to 9. And I want to solve the constraint for y. So I'm going to go ahead and subtract the x squared to the other side. So I'm going to have, y squared is equal to 9 minus x squared. And then y is equal to plus or minus the square root of 9 minus x squared. And let's remember that the reason why, the two parts come out, plus or minus, is because the positive part represents the top of the circle and the negative part represents the bottom of the circle. So we're going to choose the positive one. We chose our point to be on the top of the circle, so we're going to let y equal the square root of 9 minus x squared. Quick warning, this is not 3 minus x, right? I cannot take the square root of each part. So now I am simply going to take this whole quantity and substitute it into y over here. So I have 4x times the square root of 9 minus x squared. So the area of the rectangle is now a function of only the x variable. And we cannot multiply this 4x times 9 or times x squared, so we're simply going to leave our answer like this.